In this topic, we will be discussing about angular displacement and how to calculate angular displacement. So I've drawn a circle on this paper, and now we will put up a scenario in which an object moves from this position to this point Q, from point P to point Q. So as a reference point, I will be using a small ball. We'll put that and place it on position P, and this ball travels from this particular position to this point Q. And now we need to find the angular displacement. Now obviously this object is moving in a circular trajectory because it's following a circular pattern. So we will be thinking what is an angular displacement. So angular displacement is the angle through which an object moves from its initial position. And I'll write it down below you to look at the definition of it properly. So to find the angular displacement, we will have to measure the object's the angle traveled from this position to this position. So the angular displacement in this case will be theta. And as we know, this is the center point of the circle, and from point P to this point will be radius. Similarly for this position as well, you put radius from this point to this point. So we have radius from this point to this point. So in objects, we will also calculate the displacement from this position to this one, which is the arc length. We will say this. We will display this as the letter S. It moves from this position to this position. Now you might be wondering how we could find the theta. So to find the theta, which is the angular displacement, we will use simple maths to find out the theta. So now imagine a triangle. Both sides are equal, meaning both are radius, and we need to find theta in this case, which is the angular displacement. Now, though in this case it's not a right angle triangle, but we will still use this. This equation which we will be discussing. So, and this is the S which we talked about. So now we know that we know sine sine theta equals opposite over hypotenuse. So in this case, the opposite will be the letter S, which is the arc length, over the R, because both of them are same, so we could just take either of them, which will be R. And we are left with sine theta equals S over R. So now in this case, we will imagine that this theta is very small, so we could just remove sine from this equation, and we are left with theta equals S over R. And this is as simple as it is, that the arc length, the distance traveled of the object over the radius, and we get theta, and theta is measured in radians. So whatever answer we get after dividing the arc length over the radius, we get the answers in radians. So imagine that this delta S is 9 centimeters and the radius is 6 centimeters. So in order to find the angular displacement, what we will do is we will write theta, which is the angular displacement, 9 centimeters over 6 centimeters. And we will get 1.5, and that will be radians. So to calculate, so now you might be thinking that how much degree this is. So 1 radian equals to 57.3 degrees. So to convert 1 radian to degrees will be 57.3 degrees. So, and we will also define what 1 radian is. So imagine that this is the center, that this is the center, that this is the center point of the circle, and this is the radius. And imagine that this object travels the same arc length as the radius of that circle. So we get, so that length, that angle, the displacement is what is known as 1 radian, because it is, so what happens is theta equals, for example, it travels 6 centimeters over 6 centimeters will be 1 radian. So you might wonder why in some cases why does the radian always stay the same? 1 radian is always defined for the same scenario. So this is the reason is when we divide any, imagine it travels 9 centimeter and the radius is also 9 centimeters, so the ratio will always be same, no matter whether the circle is the trajectory is over a larger angle. The 1 radian will always remain same. The angle will always be 57.3 degrees. And I will define what 1 radian is for you to memorize it. So that's all for this lecture, and we will be discussing, one more thing which I forgot. So imagine that this object travels all the way from all through the circle. We will be getting and reaches from this whole point and moves to this point. So the displacement will be, we know that it has moved a whole circumference, and the formula for circle's circumference is 2 pi r. So the distance it has traveled is 2 pi r over the radius, and we get theta, and so the angular displacement will be 2 pi radians. So in a full circle, if an object travels a full circle, the angular displacement will be always 2 pi radians. If it travels half circle from this point to this point, it will be pi radians. And if it travels from this point to this point, the angular displacement will be half pi radians. So likewise, we could estimate how much angular displacement an object has traveled. That's all for this lecture. Watch my next lecture on angular velocity, and we will be talking about how to derive the formula for it. Goodbye.